Cooling tower performance laboratory. The basic functions of cooling tower is cool the water. We can say that cooling tower is the big heat exchanger that air and the water will mix to each other and exchange the heat. There are two types of the cooling tower. One, natural draft, and second is mechanical draft. The natural draft cooling tower is utilized the buoyancy via a tall chimney. The warm air will be raised due to the density difference between the inside air and the outside air. The warm air buoyancies produce an outward current of the air through the tower. This type of cooling tower will be used in the power plant because this type of cooling tower they need to reject the huge heat transfer from the water, and this type of cooling tower is quite very big and is need a very tall chimney. The second type of the cooling tower is mechanical draft. The mechanical draft we can divide into two types. One, induced draft. The induced draft, the blower or the fan will be installed at the top of the cooling tower, and it will be pull the air up to the top of the tower. The second type that we call forced draft. The forced draft, the blower or the fan will be installed at the intake air, and the fan will be force the air into the tower. This is the example of the induced draft counterflow cooling tower in the industry. As we call the counterflow cooling tower because the airflow and the water will be contact in the opposite directions. The hot water will be dropped from the top of the cooling tower, and the air will be flow from the lower or the bottom part of the cooling tower. Okay, the induced draft closed flow cooling tower is called the closed flow because the air contact the water in the closed directions. The hot water will be dropped from the top of the cooling tower, while the cold air will be flow through the open channel at a side of the cooling tower. Okay, this is the example of the closed flow cooling tower that we use in the industry. The component of the cooling tower. The cooling tower, at the bottom part of cooling tower there is the cold water basins, and the hot water will be inlet at the top with the distributor at the top of the cooling tower. In the exchange area, mostly in cooling tower will be used the fuel. The fuel or the filling will be helped to increase the contact area between the air and the water. Okay, how to calculate the efficiency of the cooling tower? Let's see. The thermal efficiency of the cooling tower is equal to the output, designed output, and the required input. Okay, let's see the designed output of the cooling tower, because the main functions of the cooling tower is to cooling the water, the hot water. then the desired output, it need to remove the heat from the water. Okay, and the output of the heat that will be removed from the hot water, it will be depend on the flow rate of the air, the flow rate of the water, and the different temperature between the hot air and the cold, the hot water and the cold air. Okay, the heat that we remove from the hot water we call it will be calculated from the temperatures of the hot water inlet minus by the temperatures of the water outlet. This is we call the temperature range. The temperature range is the difference between the cooling tower outlet cold water and the ambient wet bulb temperatures. Okay, and for the required input, in the cooling water can calculate by the rate from the cooling water inlet temperatures and the ambient wet bulb temperatures. Cooling tower effectiveness, or the efficiency of the cooling tower you can calculate from the thermal efficiency. The thermal efficiency is equal to the output, designed output, over the required input. The main purpose of this cooling tower is to remove the heat from the cooling tower. Then the output is equal to the removal heat from the water that we call range. Range is equal to the heat that we can remove from the water, then it should be equal to the temperature of the hot water inlet minus the temperature of the water outlet. This is the difference between the outlet and the inlet of the water. Okay, for the required input that we need to remove the heat from the water, that is input we call the ideal range. The ideal range will be equal to the range plus the approach. The range is the different temperature between water inlet and the water outlet. And for the approach, temperatures is equal to the heat at different temperature between the cold water outlet minus by the wet bulb temperature inlet of the air. Okay, this is the difference between the temperature of the water and the temperature wet bulb of the air. We call the approach. The approach is the better indicators of the cooling water performance. Okay, then the ideal will be equal to the range plus by the approaches. Okay, the performance of the cooling tower will be equal to T inlet minus T water outlet over by the T water inlet minus by T water outlet and plus temperature water outlet minus temperature wet bulb inlet. Okay, then the performance or the efficiencies of the cooling water will be equal to temperature of water inlet minus by outlet over by temperature water inlet minus temperature wet bulb inlet of the air. Okay. In our laboratory sheet, in the sheet data, in the data sheet of the cooling tower performance laboratory, okay, we will change the water flow rate and the air flow rate at the cooling load 1.5 and 1. Okay, in the equipment, in our cooling tower equipment, you have to record the temperature 1, temperature 2, temperature 3, and temperature 4, T5 and T6, which is the T1, which are the T1 and T2 is the dry bulb and wet bulb temperatures of the air inlet, and T3 and T4 are the dry bulb temperature, wet bulb temperature of the air outlet. T5 and T6 is the inlet water temperature and outlet temperature water, which is you can record them from the monitor at the equipment panel. Okay, for the specific heat, specific enthalpy, humidity and humidity of the air inlet and air outlet, you have to find out from the psychrometric chart. Okay, and then in the data sheet, the table of the data sheet, you have to calculate the cooling length, temperature at push, and calculate the efficiency of the cooling tower. Once when you record all your data from the equipment, okay, this is the personal assignment that you have to do after finish the experiment. Okay, normally the report of this laboratory will be the short report, not the it's not fully report. Okay, doing the short report with the format that Dr. Pichitra post in the SUT e-learning, and then I would like you to answer these 4 questions in the laboratory report. And what is the effect of increasing water flow rate in the cooling load? What is the effect of the cooling load in the cooling length? The effect of the increasing water flow rate length in the T approach, and the effect of the increased water flow rate to the effectiveness. Okay. Okay, in the lab sheet, there also have the psychrometric chart that you can use to find out the humidity ratio and the enthalpy. The cooling tower performance laboratory. The main purpose of this laboratory, students have to estimate the efficiency of the cooling tower. The cooling tower equipment in our laboratory, the type of this cooling tower is the counter flow. Okay, the air will flow from the bottom, and the water will falling down from the top. In our equipment, we can adjust the air flow rate. Air flow rate will be controlled by the damper positions here, and the water flow rate will be controlled by the manometer here. Okay. Then when we turn on the button here, the main button, so we will turn on our equipment. Okay. In our equipment, we have the temperature measurement equipment, this thermocouple at the inlet. At the bottom part of the cooling tower, we have the thermocouple that measure the dry bulb temperature of the air inlet and the wet bulb temperature of the air inlet. Okay? And the other thermocouple, this will be measure the outlet temperature of the water. Okay, that you can read from this monitor. At the top part of the cooling tower, we also have the thermocouple that measures wet bulb temperature and dry bulb temperatures of the outlet air and also the water inlet. Okay. Design adjust the air flowing and the water flowing. Okay, we can adjust the heat load for the water. Okay, we have the 1 kilowatt and 0.5 kilowatt. Thank